All right, and we are live. Okay, for those of you who have managed to make the pivot from GoToMeeting over to my Scythe YouTube account, welcome. We are joined by the inestimable Chenxi Wang. Thank you.
Thank you. Good to be here.
First question, which is a little bit different than, of course, your keynote topic, but I mean, you're one of those famous VC types. And I think there's a lot of misunderstanding in the community about what is a VC and what does that mean and what's their role, right? It's just so much like, well, I'm not going to take money from those folks. They're just there to drive their own profits. So if you this is your chance to set the record straight.
Well, first of all, I am a VC. I'm not sure I'm a famous VC, but that aside, a venture capitalist. The ultimate goal is to make money. And there's no question about that. Now, there are different ways to do it. There's the nice way to do it, and there's a not so nice way to do it. So the goal is to work with entrepreneurs and to collectively create a business, a company that makes difference. I've done that before on the other side as an entrepreneur, as a company executive. So I know how difficult it is to build a company, build a business. And so I think as a VC, I have empathy. I have empathy, and I know what takes to be successful and what takes to be on this long journey together. So hopefully I'm one of those nice ones that you will consider a partner rather than, as you said, we're not going to take money from those folks. So is that good enough answer for you?
Yes, that certainly sets it up. So what's some advice that you would give to some budding entrepreneurs? There are a lot of folks in the space. They're very talented. They're very bright. But the business side and actually taking that jump to starting their own company is daunting.
Oh, it is. It is. I still think it's one of the most difficult jobs to build a company. It's almost easier to have an idea. It is difficult to take the idea and transform it into a product, first of all, and then build a business around it. So many things need to go right. You need to have go-to-market expertise. You need to have a business sense. You need to have a team of people that work in different capacity to help you build the business. So it's not a one-man show. It's not a two-man show. It really is. It takes a village. And if you are successful, that is. You're one of the lucky ones, but also you've probably worked really hard. Make sure from the beginning, get the right people around you, the right partners, whether technical partners, engineering partners, product people. Get your board right so that folks on the board can support you and guide you. And another thing is a lot of people have money. And there's a ton of money around. Don't take money just for money's sake. Take money from folks that can provide more than just what's written on the check. And I think that's a really important thing to keep in mind.
How do you typically weed out some of the initial sharks that are going to be coming after great ideas or high talent, high caliber people?
So you look at who they've funded before, right? So which companies they were part of it, and you may want to talk to those entrepreneurs that are part of that portfolio and get their experiences from them. Another thing is there are a ton of discussion forums online about different VC firms, who's like being on the board. Folks are very aggressive, I would say, and all they want is get in and get a good price, and then they give you a ton of outside pressure to hit milestones and do this, do that. I think a certain amount of those pressures actually healthy, because without it, you may just be building a lifestyle business. But too much of that pressure also sort of interferes with your priority, right? So maybe you are going to be too much sales focused rather than building the right product for your customers. So there's a give and take there. So having someone who has done it before, who see the point of view from an entrepreneur's perspective is really important. And someone who give you, sort of a balanced, sound advice rather than, hey, what's the ARR this year? How come you're not there? That kind of discussion. So I would say do your homework.
That's fascinating.
So if I can call out the elephant in the room, obviously I'm a white guy, right? I have gone through the raise process. And there is a historical challenge where if you're not a white guy, that tech bro culture also goes to a lot of the VC and equity community. So what do those folks do?
The folks who are not white?
Yeah, right. They don't have that advantage.
So I'm not white. I think things are changing, albeit slowly, right? So I think there's still in the VC community, there's still a good old boys club. There's a network of VCs who get each other into a good project. They're like, oh yeah, this one's great. Let me get, Jack and whatever onto this project. But they exclude other folks. And that happens all the time. So the thing to do is discover folks who are more open-minded. Now, this kind of network, this kind of exclusive network happens when they focus on small set of criteria. A lot of VC firms say we only fund repeat entrepreneurs. So if you look at people who have founded companies before, that pool does not represent the entire pool of potential entrepreneurs, right? So, and in that pool, by definition, you'll probably get more traditional profile. So you want to go with firms that don't have that kind of rigid criteria, right? They will be more welcome to first-time entrepreneurs. They will listen to you without the bias of saying, hey, you've never founded a company before. Why would I give you millions of dollars to do it now? There are firms who don't require repeat entrepreneurs to be on the founding team, and those are the firms you want to talk to. So, for instance, we don't have that restriction, and in my portfolio, we have 45% are women founders in the portfolio, which is huge. If you think about I think the Silicon Valley statistics is 2%. 2% of funding overall goes to women founders. So there are barriers. If you remove them, you'll see more diverse entrepreneurs get emerged to the top, right? So we really look at the problem that you're tackling. We look at the talent of the team. We look at the expertise composition on the team. Like, do you only have engineers, or do you only have business people? Do you have both? Or do you have a different set of perspectives? Do you have product expertise as well as engineering expertise? Things like that give you a leg up, right? But the most important thing is, have you narrowed on a problem that is compelling to customers? So first-time entrepreneurs are they are risky, right? Because they don't know how to do things sometimes. But if they are open to learning, if they're open-minded, then they're typically more hungry. They're more into they're more creative. I love working with first-time entrepreneurs. So,
Interesting.
So
I do have one more question that hopefully you can get to before you have to start.
Yeah.
We're past time.
You're past time.
Oh, okay.
But it only is going to seem like that you were set up for that, because our theme of the GRIMMCon series is all about inclusivity and really bringing new voices to the table, because we philosophically believe that that's what cybersecurity requires, period, is more voices and different perspectives. And I think we as an industry have continually not done a good job to borderline failure on that. And so your response was perfect for that. And with that, we'd like to hand the reins over for you to bring it home with the closing keynote.
Awesome. Thank you so much. And let me share screen now. Let's see, share screen, Chrome tab. All right, I'm assuming you guys can see my screen, right? All right, I'm just gonna start, and hopefully someone's keeping time for me, and letting me know if we're getting close to the end of the time frame here. So I'm fascinated by the progress in AI in recent number of years. I'm a classic computer scientist in training. Even though I do venture capital these days, I still keep my foot on the ground. One of the things I've been studying up myself is the recent advances in AI and in natural language processing. So that's what I'm going to talk about today. And by no means I'm an expert in natural language processing. I am a student. So I'm hoping to bring some of my learnings here to share with you, and also to discuss the implications of the recent AI advances to cybersecurity. Okay, so the theme of this talk is humans versus AI, right? So we know that AI is good for certain things that humans are not, and humans are good for other things. So for instance, artificial intelligence is really good at fast speed, handling large volume data, and precision, and being consistent. And you can count down to memorize a large set of information, more so than humans can ever possibly do. Can also do very complex signal processing, which humans just would get confused. But humans are good at doing things like adaptive tasks. Humans are good at learning. We're good at creativity. We also are, at least so far, better at processing and understanding emotions. There's also the understanding of human languages that today, for certain aspects, humans are still better than AI, and we'll get into that in a little bit. And our appreciation and understanding of cultural aspects and arts, and in particular nuances, also set us apart from artificial intelligence. So there are certain things such as playing chess, do high precision surgery, and repeating sort of long running boring tasks are better left for AI to do. But humans are good at, as I said, artistic creations and complex inferences. But as I'm going to talk about in this talk, that the differences actually are minimizing as the advance of AI becoming more and more prolific. One of the things that as a computer scientist that you learn at the early stage is a test called Turing test, which is by Alan Turing, a famous computer scientist from UK. Turing, in his lifetime, asked this question: how do you tell a human from a machine? And when he proposed that question, it was scoffed by the thinkers at his time. And one of the articles I read, one of the guys said, this question's absurd. How does a machine understand the feeling of raindrops on my skin? How does a machine mimic the emotional response that I get when I set my eyes on someone I love? But Turing's response is, it doesn't matter. You may have the most sophisticated emotions inside, But if you do not communicate and show that you have that complex emotion, you're as good as a machine. So this is a very philosophical point. Let's think about this point for a second. What makes us human? Yeah, we think that we know what makes us human. We have brain, we have emotions, and there's a famous quote by Renee said, "I think, therefore I exist," right? I think, therefore I am, I think. Is that really true? If you think, but nobody knows that you think, does that make you human? Are you still human? Does a tree think? But more importantly, do we know for sure a tree does not think? Why do we think a tree does not think? And I'm not asking this question from a religious standpoint. I'm asking this question from a standpoint of how do we prove, how do we test that an entity actually thinks, is a sentient being? And I think everybody agrees that to be certified as human, or to be considered as human, you must communicate and interact. You must show that you have thinking process going on inside of you. You can process certain intelligence, information, data, language. But if you don't communicate and interact, even if you think, you are as good as an innate object, right? Only through interactions that we have, that we can demonstrate to the outside world, we have the ability to process information, to think, to reason. And that's the question that Turing was asking, is how do you show to a observing third party that you are a human and not a machine? And the question is even more nuanced than that. How do you show an observing third party consistently and repeatedly that you are human and not a machine? Now, this theme will go all the way across this talk. And let's pull back a little bit and look at things that AI is different than humans. So we all know that humans now are beaten by AI on chess and even Go, right? So chess and Go and these board games are search-focused tasks. So essentially, the computer can store all the possible moves of the chessboard in its memory. And for every response, it can search using an evaluation algorithm such as Minimax. And then it can decide on the best move, and it can even do 10 or 11 steps lookup. The best human player can probably only do 5 or 6 steps lookup. So humans are hopelessly behind in search-focused tasks, such as chess and Go and board games. So in that regard, AI already wins. So that doesn't matter, right? So we don't have to do these things. AI can win and can play chess all day long. But there are other things that we think we are better, such as image recognition or pattern recognition. Are we really better? I think AI is actually getting there. So on Google Photo today, that if you log in to look at your photos, sometimes the Google Photo will ask you, are these the same person, right? They'll randomly pick photos that they think could be the same person, and they ask you to rate them. And this is actually part of a supervised learning, right? So every time you say these are same people, or these are different people, you tune the algorithm. So for instance, here it asked me whether this is the same different person, and one of the image has this person, just the profile. Now, if I say, yes, they are same people, then the same person, then the algorithm will immediately take that into additional input. Next time the profile of this person comes up, it'll recognize, it'll make the right decision. And also, look at the 2 pictures on the left, on the bottom left here. Is this the same or different person? This is a baby picture and a boy picture. Are they the same people, same person? the computer has difficult telling. But if you are the parent or you're a relative of that person, you look at it, you say, oh, of course, the same person, right? So that's the difference between the AI recognition and the human recognition. So today's solution for AI is to increase training. The more training it does, the more training data it has, the more precision it renders, the decision that it makes has more precision. The next frontier really is natural language processing, right? So again, coming back to the Turing test, is you've got a human questioner asking questions interactively to two unknown participants, right? Could be a human, could be a computer, and the human can ask a series of questions, and based on the response that comes back, the human can decide at the end whether he is talking to an indeed human or a computer. Now, Turing, it's really interesting that he's asked this question: how do we devise a set of tests that can tell a human apart from computers? But he didn't actually really devise what those tests are. Hence, the Turing tests that have been done in the past are very mixed in quality. And this is an example of 2014 tests that were very, very controversial. And let's think about natural language processing, how computers come to understand natural language, right? So the first generation of NLP, you essentially input a huge amount of text from classic literature and whatever you can get your hands on. And the engine will pick up the sentences and will process the sentence from left to right, and will process so many sentences, and eventually it becomes, when you see a sentence says, George picked up the cup of, then it will say, okay, the word after the cup of should be a noun, and is very likely to be one of these nouns: tea, coffee, milk, or other drinks, right? So it has narrowed down from the universe of words into these set of smaller set of words. So that's what the first generation of NLP is like. But computer scientists has since then decided that natural language processing is not natural language understanding, right? So what is natural language understanding? For instance, if a computer is given these training sentences, a leaf falls, rain falls, paper planes fall, and then is given a question, when the ball is thrown, does it fall? A human would immediately say, of course it falls, because you understand all objects fall. But for an AI to deduce a ball is thrown, it must fall from the training data of leaf falls, rain falls, paper plane falls, that's actually a huge leap for the AI to do. So most AI do not perform really well for this kind of tasks, because the ability to parse the structure of language has to be combined with the understanding of the relationships between the objects that it has parsed and the meanings behind the objects, as well as the context, right? And a common sense knowledge base. In this particular case, the common sense knowledge is all things fall, unless it's, I don't know, a rocket or something. So, and without those knowledge base, without the understanding the relationships between the lexicons, it cannot be set to have true understanding of natural language, or have human-like understanding of natural language, which means that you can probably very easily tell apart a human and a machine, because humans have that context, have that understanding. So then right now in the computer science community, we have this set of tests called GLUE. It's a generative language understanding evaluation, general language understanding evaluation. It's a different set of, it's a specific set of tests that are better aligned to really understand, to evaluate understanding of a language. So for instance, and it has gone from glue to super glue, which is an improved version. This is an example, right? So if you're given this passage of text, says Bark is an American soft drink, it's a root beer, and it's notable for having caffeine, and it's created by so-and-so, and is owned but bottled by the Coca-Cola company, right? And the question then asked is Bark a Coca-Cola product? Now, a human will read it and like, yes, of course, because it's bottled by Coca-Cola, and bottled by means it's a product of. Now, for an AI algorithm to understand, it must have that knowledge base that bottled by is equivalent to the product of. Right? And if it's then asked another question, is Bark a Pepsi product? Then it will have to say no, but you will have to understand Pepsi is not Coca-Cola, and hence Bark is not a Pepsi product. So all these are sort of auxiliary language, auxiliary knowledge that the AI engine must build up to be able to successfully pass these tests. And along came GPT, GPT-2, GPT-3 to really aiming these AI engines really aimed at passing those really language understanding tests. So GPT is generative pre-trained transformers. So without getting into too much of technical details, essentially these AI models, they build an initial model with unlabeled data, right? So the first generation natural language processing requires a ton of labeled data supervised training, which is very labor intensive to do. Now these engines say, let's just give us a ton of unlabeled data, like the entire Wikipedia text base or entire Amazon book database. And we just train our engine on this unlabeled data. And we build a crude initial model. And then we fine tune the data using layers upon layers of specific smaller supervised tasks. And from GPT-1 to GPT-3, there's a huge improvement in terms of performance, precision. It went from 115 million parameters to GPT-3 now has 175 billion parameters. And from 12 layers of decoder to 96 layers of decoder. So the performance and precision has improved tremendously. And what that means is GPT-3 is now not only be able to pass some of these language understanding tests in flying colors, are also able to produce original text or even writing code that is of passable quality. And the text that it generates is actually fairly high quality, and sometimes it's really difficult for a human to tell whether it's done by GPT-3 or a human. And there's also another engine called BERT, which is open sourced by Google, has different architecture than GPT-3, but it's also extremely, extremely powerful. It has certain things that it does better, certain things doesn't do as well. But BERT and the different variation of BERT and GPT-3 can really outperform humans in certain tests. So for instance, this is another example. Okay? So I'm not going to read the whole passage, but it says, in the barn, there lived a little white kitten called Cotton. Cotton lived with her sisters and in a barn in a place on a farm. And given this paragraph, the questions asked is, what color was Cotton? Cotton was a little white kitten. Where does Cotton live? Live on the farm, in the barn, right? Did she live alone? No, she lives with her sisters. This is like a second grade reading test. Humans can pass this without any problem. And if you look at the leadership board, which is different AI algorithm is fed by this text and others, and then ask a series of questions like this. How do they perform? Human baseline performance is human get 89.4% of precision, meaning accuracy, answering the questions. That's human. And the highest performing AI gets 91% accuracy. So based on these algorithms, in this type of natural language processing, meaning interactively asking questions, humans already been surpassed by AI. Now, I promised in the beginning that we're going to talk about implications of security. So what does that mean for security, given that we have all these different advances in AI algorithms, in natural language processing, in image processing? Of course, security is all about assessing trust, right? So we want, even though we talk about zero trust, but at the end, what we want to do is have a decision, make a decision that we trust. So essentially, security is all about answering the question, is this operation allowed? This operation is about, potentially is about an identity with an action and the object on which the action is performed upon and the context of this action. And our goal is to arrive to a decision, yes or no, that we understand this decision and we can trust the decision. Right? So one of the questions that we routinely answer in question is in security is authentication. Authenticating a user, authenticating a machine, authenticating an application all the time. Now, in the old world, there's a saying that nobody knows you're a dog on the internet. And today, nobody knows you're an AI on the internet. And how do we trust you? I assert that how do we know you are you is actually a different problem than how do we tell human between, how do we tell human in general between humans and bots. So for instance, here, I can very easily tell if a particular user is that particular user by given a series of images. So for instance, I can feed a baby face that you know, only you know. Maybe not only you, but you definitely know. And then I give you another set of images and ask the human user to pick up the one of the grown-up human face of that baby, right? And then I can ask the AI to do the same thing. I don't know. Do you know which one it is? Turns out it's this picture. Now, the right user who knows this baby will always pick the right grown-up picture. Facial recognition, turns out, has only 66 to 72% confidence, given depending on the set of images that presented. What does this mean? This means that a particular human is in possession of some set of languages that the AI is just either not in possession of or not good at discerning. Right? I'm going to skip this example. Authenticating a particular human, we actually have an advantage. That's called knowledge imbalance, which is essentially what I said. You know something that can tell you apart. And it's difficult for the machine to replicate. In this case, is that this boy is the grown-up version of that baby. But it takes time and effort to curate and manage that knowledge imbalance in a way that can definitely maintain a difference between the performance of an AI and performance of a particular human. Telling humans apart in general, not just telling a particular human, but telling humans apart in general from AI is a harder problem because you kind of have to succeed in every single case and you cannot rely on knowledge imbalance. And we know there are use cases in security, right? Such as account registration. We don't want too many bots registering empty accounts. Credential stuffing, bot proliferation, all those are things that we want to tell between an actual human that's sitting on the other side of the computer versus bots. How do we do that? And we have a series of methods that we can do. I'm not talking about passwords here because that's already out of the window. So in terms of interactions, we can do natural language type of interaction. We can do audio-visual tasks, processing tasks. We can even do physical tasks, asking the person on the other side or AI on the other side do a physical tasks and evaluate the result of which. Right? So we already know that in terms of natural language processing, there's a lot of things that humans cannot be always better at doing this than an algorithm. But what about audio-visual processing? What about physical tasks? What about this? So look at this photo here. This is actually a flat image, actually a flat, not image, but printout putting on the road, but it kind of looks like 3D because the way the picture is laid out. Now, for an image processing AI, it always looks like this is a physical barrier. But a human eye, more often than not, in real life, can look at this and say, hey, this is actually flat. It's 2D, not 3D. So in this particular case, humans are actually better in making the decisions. There's also, we all know that in certain authentication cases, the web application asks us to click, I'm not a robot. Why does it ask you to click that? Because the way you move the mouse to click it, the speed and the force of which you move the mouse is human-like. And an automatic bot, it's difficult for an automatic bot to actually replicate that. And also there are other applications I've seen that ask a human to click on the screen twice the same spot. Do you know how difficult it is for a human finger to click the exact same pixel on the screen twice? It's nearly impossible. But for a machine to do it, the machine can hit the same pixel all the time. So these are differences between what humans can and cannot do and what machines can and cannot do. But as, there are one more examples here. For instance, when the natural language processing engine is given this particular sentence, my body cast a shadow over the grass, and then asked, what was the cause? The choice 1 is sun was rising. Choice 2 is the grass was cut. The GPT engines will correctly pick the sun was rising because it has built up the knowledge base. But if the sentence was given, his words cast a shadow across my heart, it is a metaphor, right? And then the questions, the choices were the sun was rising as the cause, my heart was ill, and choice 3 is his words. The AI would have very difficult time picking the right answer because it's a metaphor. Processing metaphors, nuances, and sarcasms are still very difficult for AI. So one of the research papers I read, a set of researchers actually processed a ton of metaphors using AI, and then asked that engine to produce metaphors. And it's hilarious. And one of the things the AI engine wrote was, my heart skipped a beat like a pig jumped over fire. And you read this and you're like, huh? Like, who writes that? So if you know that an AI is in the mix of writing things, you can say, hey, no, this is written by an AI. But how can you be sure this is not written by a bad writer? You do not know. So I think I will skip this. This is a really interesting example, but I think I'm out of time. As AI gets more and more sophisticated, the problem set that are easy for humans but are hard for computers, vice versa. Actually, this is probably more interesting, right? Easy for humans to solve, so you can authenticate yourself, but are hard for computers to solve. That set of problems are getting rare and rare. And we as computer scientists, as security professionals, it's actually really important for us to understand what's in that set of problems and how do we take advantage of that set of problems to write the right authentication routines, to implement the right authentication process so that we can continue to tell human from AI. But trust really gets muddy, right? So as I said, GPT-3 can now generate very high quality texts. I will give you as a homework to tell between these two examples which one is written by a GPT-3 engine, which one's written by human. In fact, a set of humans were given those different texts and they have trouble distinguishing them. It's their guesses are about as good as random guesses. They cannot distinguishing a GPT-3 generated text versus human written text. Hence the problem is going forward, fake news, fake text will proliferate because we now have an automatic way and a way to scaling up the generation of fake news and fake articles. Also, GPT-3 can write code. It can write SQL queries. It can write JavaScripts. It can also actually write code. It can more reliably write code without certain bugs than human can, which is also very, very interesting. All right, I am really out of time. So one of the things that's really interesting to think about is the very technique that used to tell a human apart from machines can also be turned around to fool the algorithm that is doing the differentiation. So it's a big arms race going on here. In order to understand how humans in this universe of AI that will be part of our universe going forward, how humans will be consistently distinguished apart from AI and will have an algorithm that we can trust doing so, it's also our job, I think, as a computer security professionals to fortify those algorithms against attacks and hacks so that we can consistently arrive to the right conclusions and decisions. So I will leave you with these questions. What makes us human? Which set of questions and tests will help us answer this question in a reliable, repeatable, and consistent way? And how do we take these tests and actually implement them in systems and applications that we use today that will have usability, will enforce usability, will actually get us to a stage that human users not deterred? And how do we fortify those algorithms so that we will continue to have this notion that we can distinguish a human user versus a computer? But as we have seen in this presentation, that the gap is minimizing. So all of us needs to think about more precisely and more deeply which tests going forward really can help us distinguish us as human versus those that communicate and interact as human. So with that, I will leave you with my contact information. Feel free to send me an email or catch me on LinkedIn. I'll be happy to continue the conversation. Now, I think I should stop sharing screen.
Yep, I got that off. So there we go. Thank you. I thought this was also really interesting to get more into the tech deep dive of artificial intelligence. Sunil's keynote to open the conference had a really interesting metaphor about talking about comparing artificial intelligence technical competence with emotional maturity, because that's a really interesting way to kind of contrast that with humanity. And we were kind of arguing about what is the age of current AI. So what age do you think artificial intelligence is today?
Oh, that's interesting. So given that it cannot reliably perform the natural language tests that a second grader can reliably perform, I would say it's somewhere below a second grader.
All right, so about under the age of 8.
Mm-hmm. But it's growing up fast.
Yeah, I was joking. What happens when it becomes a teenager?
You know, one thing you can count on is AI is not, or at least I hope, not going through this emotional disturbance as a teenager, because it doesn't need to.
Hopefully.
Bryson's not amused.
I'm actually not convinced. I think that while of course computers can't necessarily have human emotion, and there are going to be elements certainly of that science fiction genre there, I think there is going to be some kind of equivalent gap, and I think that's a lot of really what your presentation was getting at, is a lot of the innate humanity to our understanding of things in context.
Yeah.
And I think that those disturbances, particularly when we start looking about AI with the intersection of robotics, and again, going back to another theme, which ties to my work with critical infrastructure, is the impact of computers in the physical world. That emotional disturbance is, of course, a risky proposition more than just a badly written AI-driven movie script.
Yes, and I think, but understanding the current state of art for AI, and I look at some of the Hollywood movies, they're far, far apart, right? But we're not yet at Black Mirror, but we are laying down the fundamental building blocks of getting there. So the question is, where's the limiting factor, right? Can we count down those limiting factors so that we will continue to be able to tell a human versus computer? I mean, you guys all have seen Battlestar Galactica, right? Have you?
Yes.
No? Tyler,
Yeah,
you have not?
Only a few.
Okay. So when you question, one day you wake up, you're like, I could be a machine. And then
Tyler is definitely a Cylon. Check out that hair.
No, I think you look more like a Cylon, Bryson.
Wait, hold on. Whoa. Why do I look like the Cylon?
Because I know
trying
you
to
were.
fit in.
Look at your getup.
I think it's.
Sorry, I didn't mean to cut you off. What were you saying?
I think it's an interesting question that the actions, right? Can we tell the difference between AI and then as a humanity or a race or whatever we're allowing AI to do, are we going to allow them action to be able to do that? Two separate problems, right?
Yeah, two separate problems. But if you cannot tell reliably a human versus machine, then the question of whether I'm allowing it to do whatever is moot, right? Because you're not going to restrict human from doing certain things. If you cannot reliably tell, then you by definition not limiting AI doing things, right?
It's very interesting.
Yeah, that's one of the things that when I talk about artificial intelligence challenges is the need to keep the human in the loop. When something actually goes from the training to a production environment, whatever that production or operational environment is, what is the alert that dictates intervention or concern because something has come out of tolerance. And the best example I always give to that is there's the racist soap dispenser on YouTube. And if you haven't seen this video, I think it's a perfect metaphor for this problem. And again, ties back to our need for diversity, because I don't think the engineers that created the soap dispenser, where you see, a person of color trying to get the soap, and then they take a white towel and they get the soap, is the engineers did not intentionally build a racist soap dispenser. What they had was a lack of understanding of the potential range of inputs that would lead reliably, of course, to the operation that they needed to have. And that's a very simple example, but we see it time and time again with facial recognition and a lot of other these things.
Yeah, so they don't, in this particular case, there were two things. One is in the training data they used to train their recognition model, that the data itself is not diverse. And then they didn't test it with diverse data sets. Right? So both, if they had tested it, they would say, oh, it doesn't perform well with this particular set of data, so we should go back and retune our model, but they didn't. So
does the early stages of the data we're providing for machine learning now really affect what we're going to get from the perceived future?
So what's interesting is the machine learning models that we're seeing now, the more modern ones, are very, they're not set in stone in the sense that they all have different stages. They quickly build a very crude model, right? The deep learning part is you get lots of data, you build a crude model, then you tune it through many layers of improvement. So through those layers of improvement, you can make sure you can gradually build more diverse data into it and tune it so that your model can be more diverse or at least not biased.
That's where kind of the neural net and the phase functioning kind of plays in with those out loops for additional data.
Yeah, that's an example. So for an algorithm, as you said, Bryson, earlier, is setting some sort of guidelines, right? Guardrails. And so making sure it doesn't, it can bump against the guardrails, but doesn't go off the guardrails is a good thing. But where do you set? And then at some point you get into the, are we God or can we be God? That kind of discussion. That's really interesting.
Well, Chenxi, thank you so much for closing out what I think has been a way for us to all in this community find a way to close out this year. I also appreciate that we didn't end with the gloom and doom of some of the earlier talks. One of the challenges at a security conference is we are typically the wet blanket crowd who comes in and we're like, all right, so this is what's going to happen and it's going to be bad.
And you should like it.
I think that it takes all kinds, right? I love the security community because you kind of get that sky is falling crowd. But then you also get the other crowd that are really into protecting assets, protecting people, and it's really coming from the more positive side. See the both sides, and at least for me, I really enjoy it. And I'm always optimistic if you know me.
Well, we want to thank you so much for joining us today. We're going to bring the conference here to a close. Except for we do have the happy hours for those of you on Discord. The links are out for the different happy hours. They are somewhat space limited because we can't have everybody in. GRIMMCon 4 will be announced in the next couple of weeks, so stay tuned. Particularly if you know any new speakers. That is one of the things that I think makes this conference really special is we're looking for new speakers who need to get over that imposter syndrome, or they need help with their research, or anything that we can do to bring those different voices to the table here. I think one of the neatest things for us ending out this year with GRIMMCon 3 is we had several speakers who graduated from GRIMMCon 1 and 2 to the expert track, have gone on to speak at SANS and other conferences. And that's what it's all about. And that's what we need
awesome.
More of. So if you want to be a coach, you want to be a volunteer, you want to be a new speaker, look for that CTF. We're looking for you to help do it. CFP. Speaking of capture the flag.
What are you doing in the happy hours? What are you doing in the happy hour on Discord?
Yeah, so happy hours are going to be through Google Meets. I will send you an email with the details of the different happy hours. I'm hosting one. The ICS Village with my co-founder, Tom Van Norman, is hosting one. I believe that we have a sci-fi one, so the Cyber Physical Lab, which is the parts of Grimm that actually that hack all of the physical stuff. And then I believe, did I say Red Team Village already? I think Red Team Village is also having a happy hour. So I'll get you those details. We would love to have you join whichever one. Of course, mine's the best, but just saying, whichever one you want to, join. There's no Cylon preference here.
You might get one link.
No Cylon preference.
So thank you to John Hammond and the team for running the Capture the Flag for today. The winner with a large lead is Ampun Bonjago. I don't know how to pronounce that. They are the winner of a drone, which we hope that they will also hack. For those of you who didn't see the DJI hack that made the news this summer, that was Grimm with partner Synactive who led that research. And then Yakuhito, who is going to win one of our CTF avatars, which is the Grimm Toaster. If you haven't seen it on Twitter, iToaster, it will talk SPAC. And then last of all in third place is Jibe, who's going to win a custom backpack filled with stickers and swag. For those of you who haven't seen it, we also have the sign up on Discord for the Grimm stickers and swag giveaway for different prizes. And then I really want to say thank you to, first of all, my co-host Tyler for the track 1, Jeff McJunkin who helped run the noob track with track 2, the dozens of volunteers who helped run the villages, who helped run the career hacking with resume reviews and mock interviews, who just helped make the whole thing. The day really is what special as much as we can. And look forward to seeing all of you in a better and brighter 2021.
Thank you.